our finding zeros of polynomial functions here, we're going to up it just a little bit because, yeah, we found zeros of this polynomial function already, or ones like it, because it's just an x squared. But let me make a little point about this one that may help us when we have a degree that's going to be greater than 2. Degree 3 or degree 4 is really what we're going to be considering here. All right, so zeros are what makes the function value 0, right? And the way we did this one was we factored it. So what are the zeros? Well, we could say, well, this one factors. So let's do that first. 2x and x. Minus 2 here and plus 1 there, right? That'll be the factoring. And then I want the zeros, and so it's what makes the function value 0. So I'm just going to set these up equal to 0. And those will be my zeros. Subtract 1, divide by 2 here. So we got a -1/2 is one of the zeros, and of course add 2 here. So those two are my zeros for this function. Well, the point, okay, so we've already done that, but the point I wanted to make was we talked about last time the synthetic division, and turns out if I use either one of these in my synthetic division, let's use 2 here, to divide into my function. So in synthetic division, we just put alongside that, we'll put the coefficients. So it'd be 2, -3, and -2. Let's notice something here about what happens at the end. All right, so synthetic division, bring this one down. Then we take the 2 times the 2, gives me 4. -3 plus 4 is 1. And then 1 times 2 is 2. And then -2 plus 2 is 0. And that's the thing I wanted to mention was, notice there that when I put in, when I do that division, the remainder is 0. And the same thing happens if I do the -1/2. See what happens there, bring down the 2. 2 times -1/2 is -1. -3 plus -1 is -4. -4 times -1/2 is +2, and then add those, you got 0. So in both cases, so it's not a coincidence there is what I'm saying, that when I have a 0, what's going to happen is if you do the synthetic division, you get remainder of 0. Okay? So if k is a 0, or whatever you want to call it, then the remainder using synthetic division, or whatever division, doesn't matter really synthetic, but it's really just division, but we're going to, of course, use synthetic division, is 0. Now, for our purposes, we're actually going to use the converse of that, and the converse of that is true as well. If we get a remainder of 0, then k itself is a 0. We could try other numbers, divide other numbers into this, but those other numbers are not going to give us a remainder of 0. So it is a one-to-one correspondence there. So the converse is true too. And that's the way we're going to use this. Because when we start with a 3rd degree and a 4th degree polynomial, we're not going to know how to factor it. Probably, unless it's some type of special factoring that we can use, like grouping or something like that. But if we can apply this synthetic division, then we're going to be in good shape. All right, so here's our next step. All right. Now, also here, because I think this is the way one of the problems in the book ask it. So, and I just erased my function, but so it was f of x equals 2x squared minus 3x minus 2, which was also in factored form 2x plus 1x minus 2. Is that right?
Yes.
Well, focusing on this one in particular, also note there, and we mentioned this before, but k is a 0, x minus k is a factor. Because we had 2 was a 0, x minus 2 is a factor, and so that just, I want to just reiterate that the two go hand in hand as well. All right, so with that in mind, let's find the zeros of f of x equals 2x cubed plus x squared minus 12x plus 9. Find the zeros of f of x equals 2x cubed plus x squared minus 12x plus 9, given that one of the factors is x minus 1. I believe this is the way this book will ask this particular problem. Now, to fit it into what we were just saying about synthetic division, so if k is a 0, then the remainder is, using synthetic division, is 0. What's the 0? So if I've got x minus 1 is a factor, what's the 0 that?
1. X equals 1.
X equals 1, all right. So that means x equals 1 is a 0. So we've got one of the zeros, all right? So this is good. So if 1 is a 0, then let's plug it into our synthetic division, and that confirms it. So again, we're going to use this 1, not minus 1. We use the 1. All right, then alongside that, we plug in our coefficients, 2, 1, negative 12, and 9. So yeah, let's use our synthetic division to confirm it, but there's more that comes out of that. There's more that we can figure out just from that one little piece of information. All right, so read it down. The 2 times 1 is 2, 1 plus 2 is 3, 3 times 1 is 3. Negative 12 plus 9 is negative 9, and then negative 9 times 1 is negative 9. 9 plus negative 9, ta-da, okay? All right, so really that didn't give us a 0 because we already knew that one. But it did confirm we've got a remainder of 0 here. So that confirms that it is a 0. But here's what else that gives us, though. Alongside here, remember that's the coefficient of our quotient. All right, and so that would be what? 2x the second, be 1 less, 2x the second, plus 3x minus 9. Okay? So what that does for me is, yeah, this is x minus 1 is a factor, but what this also is a factor of the function. Because x minus 1 is a factor, and so it'd be x minus 1. If I wrote it out, it'd be x minus 1 times this. Since I'm trying to find the zeros, though, can I find the other zeros off of this? Because if this is a factor, set that equal to 0. Yeah. So the next step here, so step 1 is use synthetic division. Step 2 then is take the coefficients of the quotient, put them in there, and then set that equal to 0. So now we solve this, and that'll find our other zeros. With me? I believe it factors, you know, you have to use the quadratic formula, okay. But I believe it factors 2x and x, yeah, 3 and 3. It's going to be a plus 3 here and a minus 3. So 2x minus 3 and x plus 3, because that and that's 6x, and that's minus 3x. And you add those, you got positive 3x. So, solving that equal to 0, now we've got factors, and we can set those equal to 0, add 3, divide by 2 here. So we've got 3 halves, and we've got minus 3, so it's negative 3. So my zeros here, we knew 1 was a 0, because that's, on these problems, that's what they're wanting. They're wanting the zeros, and so we've got 1 is a 0, 3 halves, and minus 3. Okay. All right. So that's how we can do it for a cubic one. Really, what it amounts to is all I have to do is find one of them, find one of the zeros, and then the others by synthetic division I can find them using that quotient that we come up with. Okay? All right. Now, here's the next step. What if they don't give us any of the zeros? Because that's really, I guess, what we're working our way towards. Well, if we're given a polynomial function, 3rd degree or higher, and we don't have any of them, here's what we're going to use. Here's the next step. This book calls this the rational zeros test. Other things may call it something else, but here's what it is. For a polynomial function, where A is the leading coefficient, and C is the constant, any rational zero of the function will be of the form P over Q, where P is a factor of C, the constant, and Q is a factor of A, leading coefficient. Kind of wordy, isn't it? But here's what it amounts to. If we've got a rational zero of our polynomial function, it'll have to be, and all a rational number means is it's one number divided by another number, and that's why the P over Q there. So rational zeros of this form, P over Q. And that just means P, you've got P is going to be a factor of your constant over Q, which is a factor of the leading coefficient. what this gives you is a way to generate a list. And a couple of them will generate the full list. But let's just generate that list for this this function right here, and just compare what this means. All right. So what they'll do is the possible rational zeros. That's the way they'll ask it here. What are the possible rational zeros for my f of x equals 2x cubed plus x squared minus 12x plus 9? We already know the zeros, but let's list out the possible ones just based on the equation, all right? And so these possible rational zeros are this p over q. And so in this case, p over q would be factors, you're going to do all the factors of the constant divided by all the factors of the leading coefficient. Now in this case, what's our constant?
That would be C, right?
That's our C. It's the constant here, that's our constant. So it's 9. So in this case it's 9. The leading coefficient, that's the 2. So it'll be factors of 9 over factors of 2. Well, 9 has a lot of factors. Well, not a lot, I guess, but it's got 3 factors. 1, 3, 1, 3, and 9 are factors. But not only 1, 3, and 9, but the negative counterparts of that. So we could add plus or minus to all those. And then 2, well, plus or minus 1, plus or minus 2. Not a whole lot of factors of that, but so the list then, you just take all of these and divide them by all of those. So you got 1 divided by 1, plus or minus, so it would be plus or minus 1. You got plus or minus 1 divided by plus or minus 2, so that would be plus or minus a half. Then you got 3 divided by 1, so that would be plus or minus 3. 3 divided by 2, so it would be plus or minus 3 halves. Then you got the 9, so it would be 9 over 1. So that would be plus or minus 9 and plus or minus 9 halves. So that's the possible rational zeros here. And you know those lists can get long depending upon your numbers that you have, but they just want you to see that this is the possible rational zeros that we've got. Okay? Now, out of those possible rational zeros, are these 3 in that list? Do I have 1? Yep, positive 1's there. Positive 3 halves? Yep, positive 3 halves there. And negative 3. So all 3 were in that list. So this is not saying that all these are zeros. These are the possible ones. And the actual ones are in that list. Okay? All right. So let's do, any questions about that? With me? And so that's the list that's going to help me find the zeros if I don't have any idea what the zeros are. If it doesn't give me one of the zeros or a factor, I'm going to have to start with that list, or thinking about that list anyway. Okay, so let's take a function here. So it's f of x equals 2x cubed plus 3x squared minus 8x plus 3. Make sure that's right. So I've got my paper, so we'll go with that. All right. So a part of this. Let's just list the possible rational zeros. All right, right? These are just possible ones. These aren't the ones. These aren't all zeros. These are just the possible ones. Using this rational zeros test is what they have in mind. Okay, and so the possible rational zeros are, so I do what? I do the factors of the constant divided by the factors of the leading coefficient. Well, here's my constant. Here's my leading coefficient. So the list would be, well, this one's a little bit easier because if I do the factors of the constant, it's just plus or minus 1, plus or minus 3, right? Then the factors of the leading coefficient, 2 and 1. So it's plus or minus 1, plus or minus 2. And so the list is going to be, take each one of these, divided by each one of these. So it'd be plus or minus 1, plus or minus a half, plus or minus 3, plus or minus 3 halves. So that's my possible ones. See where I get those? It's just factors of this divided by factors of this. Okay. Well, what is the point of that? Besides just being for fun there. Well, again, what this does is this gives me a list to try. So now, on B part here, what are the zeros? Let's find the zeros of f of x.
So we're going to plug those in for synthetic division.
Aha.
And find
So
which ones don't have
we're not given anything to try, but we have a possible list. Now, they may not all work. And so let's start with -1, just to start with one here. May not be the one we'd start with, but let me start with -1 just to make a point. All right. So try a possible zero in synthetic division. And if that one doesn't work, try another one. Okay. Hopefully it will.
So we're looking for a zero at the end, correct?
We're looking for a zero. So to be a zero, for the possible zero to be a zero, you have to have a zero remainder, okay? So you need a zero remainder. Based on our previous discussion there. All right, so does -1 work? So I'll take -1. Here's my coefficients, 2, 3, -8, and 3. Bring down the 2, so 2 times -1 is -2. 3 minus 2 is 1. 1 times -1 is -1. -8 minus 1 is -9. And -9 times -1 is +9. Uh-oh. That was not going to work, is it? So I wanted to do that one just, they won't all work. So -1, reject that. Well, let's try the next one. Let's try +1. So do the same thing out of this list. Start wherever you want. But so +1. Does that one work? 2, 3, -8, 3. Is that one going to work?
Yeah.
Yes.
I was thinking it should. So good. Zero remaining. Yes. Aha. So we found 1, but we've also found some more, haven't we? Because what does this give me? The 2x squared plus 5x minus 3, right? Because we go 1 less power. Now if we set that equal to 0, that's going to give me my other ones. So really, for these third degree, if we find 1, then we found the other ones. We don't have, you can go through the list, keep going through the list if you want to, but this will be a much more direct way because now we can just solve that, which we've got options to solve that because it's a quadratic. We can use quadratic formula, we can use factoring. See, 3 and 1, plus 3 and minus 1, 2x minus 1, x plus 3 will be the correct factoring. Does that, and that's 6x. and that's minus 1x, add them, you got 5x. Okay. So that set to 0 individually gives me my other add 1, divide by 2. 1/2 and -3. So there are my zeros. Okay? 1/2, -3,
Alright.
positive 1/2. It's okay? Any questions about that? All right, so what if I have a 14? Let's talk about that. So let's find the zeros of x to the 4th, f of x equals x to the 4th, minus, 2x to the 4th, plus x cubed, minus 28x squared, plus 9x, plus 36. Make sure that's right. 2x to the 4th, plus x cubed, minus 28x squared. Okay. Find the zeros. So we're not given anything to check. We have to come up with that on our own. And so yeah, let's think possibilities here. I mean, there are some. I mean, I'll probably ask you on possible rational zeros on the test to list possible rational zeros. So let's do one more of those where we list the whole list out. This is going to be quite a few because, yeah, you've got factors of 36 divided by factors of 2. So that's quite a few of them. But let's go ahead and list them out just to get a little more practice here with that. So it'd be plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 4, plus or minus 6, and plus or minus 9, and plus or minus, oh, that's too much, 18, no, 12. Well, let's just, all those, whoops, got one more. Yeah, that's quite a list for 36. So it could be quite lengthy. And then factors of 2, yeah, plus or minus 1, plus or minus 2. All right, so each one of those divided by, each one of the top divided by each one of those. I won't list them all out. That suffices, I think. If you got that, you hopefully understand what we're doing there. Okay? Is that all right? So there's quite a few of them. Now, some of them actually overlap because look, you got 2 divided by 1, but you've also got 4 divided by 2. That's the same, isn't it? Both of those are 2. So some of those are overlapping. You've got 6 divided by 2, which is the same as 3. So anyway, that's quite a list. So which one do you want to start with? It's up to you, I guess, but I'd probably start with the ones, plus or minus 1. Just to try something. Does 1 work? Thinking it again works, won't always. But. Oh, and the other thing too, remember, look out for missing terms. There's no missing terms, so be careful with that. Let's see, so 2, bring down the 2, so 2 times 1, 1 plus 2 is 3. 1, so that's negative 25. Negative 25. Oh, it doesn't work, does it? That's negative 16. Go. All right, so 1 doesn't always work. How about negative?
128 wouldn't it be 3?
Oh, yeah, that's what I did wrong. I thought 1 would work. Oh, no, it's still there.
That's still wrong anyway.
Yeah. I put the wrong number there, but I had the right number there. I was talking and writing at the same time. Sometimes that doesn't work. Yeah, so let's go with -1. So that's 2, 1, -28, 9, and 36. So hopefully you don't have to try too many to get one that comes in correctly. There's one right there. Aha. So -1. Now we have another dilemma here though. Because what does this give me? What are the coefficients here? Of 2 would be of x cubed, yeah. 2x cubed because it's one less than we started with. I started with x to the 4th, so this is 1 less power of 2x cubed. Minus 1x squared minus 27x plus 36. The dilemma is, well, I've still got a cubed. Unlike the previous one where I had this came out to be an x squared, which I know the quadratic formula at least, or factoring, but I still, well, I can do the same process on this that I did on that. When I start with 2x to the 4th, now it's a 2x cubed, so I can use my synthetic division now on this one. All right? Instead of doing synthetic division now on that, I've at least lowered it by 1. So I've done a little bit of it. I found a 0 and I've lowered this to a cube. Now, so I put these in my synthetic division. Now, if 1 didn't work here, it's not going to work there either. So that eliminates that one. So we can try 2. Something like that, since I know 1's not going to work, didn't work in the other one, so it won't work in this one.
Would you use -1 again or no?
You can try -1 again. Sometimes it, unless it's a double root though, it won't work.
That's just move on to the
So it's probably best just to,
2 doesn't work.
2 doesn't work. How about 3? Yeah. 2, -1, -27, 36. It is?
I think it worked.
Okay.
Choose by -12 0.
Here we go. All right, so now the coefficient, so we've got 3, we've got -1, and now we've got, what's this, 2x squared? Why is it squared?
Because we took one away through the synthetic division.
Yeah, I'm synthetically dividing x cubed, and so now we're down to an x squared, and that's a whole lot better for us because we know a little more about solving those. And I believe these do typically factor. I mean, maybe they won't, but nothing else. We use the quadratic formula. So it'll be 2x and x, 3 and 4, 6 and 2.
I think 3 and 4 isn't it?
3 and 4. Oh, 4 here and 3 there. Yeah, okay. Plus, minus 3, plus 4. Yeah. It's 8x and minus 3x. Yeah, those combine to be 5x. Got it. So we've got 3 halves. -4. So my zeros are, we got -1 and +3. 3 halves and -1. And one other thing we might note here is that how many zeros did I wind up with? 4. What was the degree that I started with? 4. Yeah, so the number of zeros, if you count multiplicities and all that, sometimes if you have multiplicities, the number of zeros will match the degree. So we've got 4 zeros, we got a 4th degree. If you look back on the 3rd degree ones we did, we had 3 zeros, 3rd degree. Yeah, so that's the number of zeros you're looking for. All right. Anything further on that?